All right, this is a quick video of testing the 240SX digital gauge cluster flexible PCB. That's this part on the back of the cluster. We're going to first remove all of the light sockets, and then we're going to make sure that nothing is connected to the cluster. And then we will set our multimeter to ohms. That is this setting right here with the ohm symbol. And then we will test the diodes and the resistors on this circuit board. Okay, quick. I actually have the multimeter in this video in the diode setting, which you might want to do, but it'll also work in the ohm setting. And the diode symbol is this one right here. It looks like it's this one right here. Actually, I have a picture, right? Looks like that. So that's diode setting. It'll give you like a voltage drop across the diode, and it'll probably make a beeping sound. But you can do it in ohms, and maybe with the cheap multimeters, I would recommend doing it in ohms. But you'll get a slightly different reading than me, but it's no big deal. You should still get OL on one side and a reading on the other. So the diodes are going to have this symbol like this. It's going to be what looks like an arrow pointing towards a negative sign. And the important thing to know here is that the positive side of the diode is going to be the side with the arrow, and the negative side of the diode is going to be the side with the flat negative sign there. And the resistor doesn't matter. Okay, so we have it set to ohms. We're going to find, so there's our diode symbol. So we know that this diode, the positive is up here and the negative is up here. So I'm going to take my positive, put it on there, and then I'm going to, let me get this so you can see it. And the negative on the negative, and we can see that we're getting a reading of 0.573 volts. So that's a drop in voltage of 0.573 across the diode. And then we're going to reverse it. So then we're going to put our negative on the positive side and our positive lead on the negative side of the diode, and we should get OL. We should not get any reading here. If you have a reading here, then your diode is bad. All right. Next, let's go to the next diode, which is up here, right above the further connector. And let me put that in a spot that we can see it. Okay, so negative is this side, positive is this side. So I'm going to put my red on the positive, my black on the negative, and we're getting a reading of 5.67, so that's good. And then we'll reverse it, and we should see OL. Okay, so that's good. And then we will go to the final diode, which is over here. So the diode and the resistor are actually right next to each other. So the resistor symbol looks like this. You can see that resistor is inboard from the diode, so the diode is further to the edge here. So we'll test the diode first. This side is the positive of the diode. The diode symbol is right here. And that side is the negative. So we get a reading of 5.7 or 0.57. And then if we reverse it, we should get OL. We should not get anything on this reading. And we don't. And then lastly, still in the ohm setting, we're going to test the resistor, which we can peel this back and actually look at the ohms that it should read. So if you look at your resistor, it should give you a reading or a number and then the ohms symbol. And this one says 36, and it's going to be plus or minus 1 or 2. So So and we get actually I gotta switch out of diode mode here. There we go. And we get 36.1 ohms. Okay, I actually missed a diode. And earlier I was in diode mode, but you can do this in ohms mode. I didn't realize I was in diode mode. But there's actually one more diode right here, which is directly below the uh, leftmost connector. And you can see I get OL and 0.430 mega ohms. So that's good. And then after we do that, we want to test every single trace on this PCB. And that sounds like it's going to take, I'm not going to show every trace on this PCB that you need to test, but it's pretty simple. You just pick a point. So we'll start out with all of these connector traces. So we'll touch the bottom that's exposed copper. So like down here, we'll touch the bottom and then we'll follow that trace. And we see that it goes to this screw here. So we're just going to touch it while we're still in ohms mode. We should get very, very minimal reading here. It should not be even 1 ohm, really. It should be like 0.1, 0.2, or 0.0 in this case. And I'll do another one. So we'll do one with the diode. So we'll choose this diode and we can follow it. It connects to this diode as well. And then it also connects to where the light connects into. We can see we're getting 0 ohms. This is a bridge right here. It's actually a trace that's just soldered in. We can test that. So we have 0.5 ohms. I don't know if there's any other bridges. All right, and just to be clear, to clarify, the reason we're doing these traces is when we go from point to point, we're verifying that the 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 trace in between those 2 points is good. If there's a really large ohm, or if it's OL between 2 points of a trace, then that part of the trace is bad. And the reason we're doing that, especially, would be where the previous owner, soldered bridges over top of some of your connection points. You really want to test those traces in particular. So, and I saw 2 of those, I think. So, like if there was a soldered joint like right here, you would test from here to wherever that goes, to wherever that trace goes. And then, if it's fluctuating a lot, or if it's like, 53 ohms or mega ohms or something ridiculous, like over 1 ohm, really, then that trace is bad and it needs to be fixed. That, or your copper is dirty and your connection point with your multimeter leads is not connecting to clean copper. So if your leads are connected to clean copper and you're getting a ridiculous reading, then that trace in particular is bad and it needs to be fixed.